solving by elimination. And I think this, you will like. What other ways have we done solving systems of equations before by? Substitution. Graphing. Maybe we'll do one here. Shoot, I want an easy one here though. Well, I wanted to show you. I wanted to review one. Hold on a second. Just a minute, kids. Let me find my way back to. No, go give me under systems of equation. What was an example like? Give me an example that I gave you for substitution. Throw me one of the examples from your notes that we did. Just give me that. Like the very first one. I don't even care if that's what it is. Maybe I won't that one. Nobody has it? Just any of them.
Y equals x plus 3, y equals 2x plus 1.
Y equals 2x plus 1. Alright. Substitution-wise, remember you put this, didn't matter which one, you put one into the other thing. Let me just quickly do that. Substitution looked like this. Substitution. You took this, put it in for y right here. So you got 2x plus 1 equals x plus 3. Subtracted x, you got x minus 1 minus 1. X equals 2, right? And then y equals 5. Correct? Yes, just go with that. Okay, that's substitution. Then we also did graphing, which was the first way we did these things, where y equals x plus 3 and y equals 2x plus 1. When you graphed it, you just did crosses the y-axis at 3. It had a 1 slope, so up 1 over 1. Looked like this. Y equals 2x plus 1 across that 1. The slope was positive 2, so it went up 2 over 1. Up 2 over 1. Boom. And the place where it crossed was your answer, which is 2, 5. Hopefully that was 2, 5, right? Yes. Now today we talk about elimination. And unfortunately, I don't think I like that one for elimination. Let me give you this equation here. Write down this one. 7x plus 3y equals negative 5. And negative 2x minus 3y equals 5. Maybe I don't like this one. Wait a second. Sure, I do like it. Not bad. Okay, if you look at that, which way of those first two looks like it would be easy to do? Is it easy to graph those lines? Well, in order to substitute, what would you have to do in order to be able to substitute something in? You'd have to solve one of them for a letter, which means it would look like this. Let's say I solve this top one for y. I get 3y equals, subtract your 7x over minus 5, and then solve for y, you'd have to divide by 3. So you would have to put this in for y right there. Okay, not so much. That's why elimination, ladies and gentlemen, is probably the absolute most fun and easiest one to do. Check this out. Okay, elimination is just like it says. It's just like it says. What your goal is by adding or subtracting. Okay, you want to, oh boy, I can't spell want. You want to eliminate one of the letters. And it's based on this one simple fact. Check this out. If you have 7 plus 8 equals 15, correct? And 9 plus 2 equals 11. If you add these two equations together as they stand right now, 9 plus 7 is 16, 8 plus 2 is 10, and 15 plus 11 is 26. If you add two equations together, you get an equation that's true in the end. Okay? In other words, this equation is true just like those two are true. Well, here's the deal with this. Let me get another box here. If I take, and in this case it worked out really easy because I set it up to do that. If you take 7x plus 3y equals negative 5, and then you have minus 2x minus 3y equals negative 5. If I add these two equations together or combine them, what happens? What's 7x minus 2x? 5x. What is 3y minus 3y? No y's. What happens is this term, the y terms have actually all gone away. What is negative 5 plus negative 5? Negative 10. And then if you solve this, since it's still a true equation, you get x to be negative 2. Without having to graph it, without having to do all that substitution sort of stuff. You still have to, though, here comes the hard part, they get a little more tough to do. You still have to plug this negative 2 in for x over here somewhere to see what y is. So you're going to have to take like 7 times negative 2 plus 3y equals 5. So you get negative 14. Add 14 to this, you end up with, I believe, 9. 3y equals 9, so y is going to equal 3. If you can do elimination, which you really can on all of them so far, it makes it much quicker and much simpler. It's certainly a lot easier than graphing the lines. Okay, sometimes sometimes substitution works depending on what the equation looks like, but that's probably one of the easy examples. Let me give you a harder one. And maybe you should write down some rules. How about this one? 5y. Here's probably the best one to write down. If you haven't focused till now, focus on this one. 5y equals 8x minus 2. And 4x minus 3y equals negative 2. Did I write that down the right way? Look at it here. Oh no. Oh well. I guess we jumped right into a hard one here, sorry. First thing I'm going to have to do is, first thing you need to do is you need to arrange the terms so that x's are above x's. You arrange the equations so the letters or the variables line up. You want to write it in standard form, which means you want your x's and y really to be on the left side. Okay. So work with me here. That means on this top one, I need to subtract my 8x over to this side. So I'm just going to subtract 8x over here. I get negative 8x plus 5y equals negative 2. Stop me if you didn't catch that. I just moved the 8x term to the left side. Subtracted it over. On the bottom one, it already is written like that, so I just rewrite it. It is 4x minus 3y equals negative 2. So far, so good? Now, if you look at these, children, why this does this? If you look at these, there are none of them that if I add together are going to drop out, correct? If I put these together, I'm going to get a negative 4x. I put those together, I'm going to get a negative 2y. It doesn't matter for the numbers. So, any thoughts as to what we can do? If you remember back, even last year, one of the things that you might need to do is remember the rule that says you can multiply every term by the same thing of an equation. In other words, this. In order for these x's to drop out, what would this if this is a negative 8x, what would this have to be for it to drop out?
Positive.
A positive 8x. They have to be opposites. What would I have to do to this to make it a positive 8x? Multiply by 2, which I am allowed to do if I multiply every term by a positive 2. Okay, so this now becomes a positive 8x. This is a negative 6y, and this is a negative 4. So now I can use this new equation, and then step 3, okay, either add or subtract. Actually, let's just say add together. I add these two equations together. Negative 8, positive 8, it goes away. Negative 6y, positive 5y is negative y. Negative 4, negative 2 is a negative 6. So what does y equal? 6. Make them both positive, y equals 6. And then your last step is always to substitute in and find the other letter. Substitute for other variable. So I need to take my positive 6 for y, put it in for y, doesn't matter which one, and then solve for x. 5 plus 6 is 30. Subtract 30 from negative 2, you get a negative 34. Wait, I'm sorry, this was 30, right? You get a negative 32. Negative 8x equals negative 32, so x equals positive 4. What do you think? You're going to say